Hello everyone, this is Dr.Sr.Stanis Arul from the Department of Mathematics, Nirma College for Women, Coimbatore. In this video, I am going to a simple and special case of graphs which are known as bipartite graphs. So, before knowing what is a bipartite graph, if we know what is a graph and complete graph, then that will be more helpful for us to understand the concept of bipartite graph, regular bipartite graph and complete bipartite graph. Generally, the graphs are defined as the collection of vertices and edges. Here, the vertices are denoted by the capital letter V and the set of all edges are denoted by the letter E. Also, the vertices are also called as nodes or points, and the edges are also known as lines or links. For an example, consider this graph G having 4 vertices V1, V2, V3 and V4, and the line joining the vertices are known as the edges. So, for this graph, we have the edges E1, E2, E3, E4 and E5. So, the vertex set V has 4 elements V1, V2, V3 and V4, so that the cardinality, that is the number of elements of V, is 4, and the edge set E has 5 elements E1, E2 etc. up to E5, such that the cardinality of E is equal to 5. Next, we define a complete graph, which is nothing but a graph in which every vertex is connected with every other vertices of a graph. For an example, if you consider K1, we have a single vertex, because generally we denote the complete vertex by Kn, where n denotes the number of vertices of a graph. So, in K1, we find a single vertex. That vertex is also called as a null graph or empty graph. Then, to define K2, we have 2 vertices connected by a single vertex. Here, if you see, each vertex is connected to each other. And similarly, K3 is nothing but a triangular graph in which we find 3 vertices, and every vertex P1, V2 and P3 are connected with the other vertices. So, we can also define K4. For K4, we need 4 vertices V1, V2, V3 and V4, and to be a complete graph, every vertex must be connected with the other vertices. So, V1 must be connected with V2, V3 and V4, and V2 must be connected with the other vertices, and this is true for other vertices also. So, this is a complete graph with 4 vertices. Similarly, we can find Kn for any values of n. Next, we define a bipartite graph. In a bipartite graph, the vertex set is partitioned into 2 subsets x and y, such that the union of x and y gives a whole set V, and the intersection of x and y is empty. For an example, if we consider this square graph, here we have the vertex set VFG is equal to 1, 2, 3, 4. Suppose if you consider the edges to be E1, E2, E3 and E4, now consider E1. In a bipartite graph, if you consider any edge of a graph, one end must be in the partition X and the other end must be in the partition Y. Now we have to check whether this square graph is a bipartite graph. So I choose a edge E1 in which one end is 1. I choose this as an element of X so that the adjacent vertices cannot be in X, so that they can be found only in Y. Next, we move on to the vertex 3. 3 is adjacent to both 2 and 4. Therefore, they cannot be found in the partition Y. So, there is a possibility that 3 can be found only in X. So, these are the partitions, and when you find out the union of X and Y, we find the whole set of G, vertex set of G, and when I find the intersection, we get an empty set. Therefore, the partition here is proper, so that we can conclude that the given square graph is a bipartite graph. Next, we define a regular bipartite graph, which is a bipartite graph in which the cardinality of X is equal to the cardinality of Y. So, generally we define the bipartite graph by Km, N. When I say the cardinality is equal, here the cardinality of X is nothing but M, and the cardinality of Y is denoted by N. So, for a regular bipartite graph, we can find M is equal to N. For an example, if you consider this graph, here the vertices are V1, V2, V3, V4, V5, V6, V7 and V8. Now we have to find out X and Y. Suppose if I choose V1 in X, then the adjacent vertices V2, V5, V4 can be only in Y. V2, V4 and V5. Next, when we move on to V3, then the adjacent vertices. V3 is not adjacent to V1, therefore V3 can be found in X. So, the adjacent vertices of V3, they are V7 and V4, V2, already they are in Y, therefore we can only find out V7. Next, the next vertices V8 and V6 are non-adjacent to V1 and V3, therefore that could be in X. Now, we have cardinality of X is equal to 4 and the cardinality of Y is also equal to 4. Therefore, this graph is an example for a regular bipartite graph. Next, we define a complete bipartite graph, which is a graph in which the vertices in the partition X are connected with all the other vertices of Y and vice versa. That is, every vertex of Y will be connected with the vertices of X. For an example, if we consider this graph, here we have 6 vertices and the partition can be X and Y, X is of elements V1, V2, V3 and Y is of elements V4, V5 and V6. Now look at this V1. This V1 is connected with V6, V5 and V4. These 3 are the elements of Y. And similarly, when you consider V2 and V3 also, they are connected with all the vertices of Y. And when you consider the vertices in Y, they are connected with the vertices of X. Therefore, this is an example for complete bipartite graph. Using these definitions, we can prove an important property of graph. The property is that the graph is bipartite if and only if it contains no odd circle. This is easy to prove. So, before proving this property, let us know what is the cycle of a graph. A cycle in a graph is defined to be a closed path whose origin and terminus are same, and in the path no vertices and edges are repeated. For an example, if we consider a triangular graph, in this graph we have 3 vertices and 3 edges. If you start from V1 and you can reach again this V1 without repeating the vertices and edges of the graph. Therefore, this is known as a cycle, and this cycle has length 3 and number of vertices of this graph is 3. Therefore, this is known as cycle C3. And similarly, if you consider a square graph also, then it contains 4 vertices and it is a closed cycle. So, the number of vertices are 4, hence it is called as C4. So, when I say R cycle, the number of vertices of the cycle must be R. So, according to the property, when I say a graph is bipartite if and only if it contains no R cycle, to be a bipartite graph, the graph must not have any cycle. For an example, if you consider this R cycle and when you find out the partition x and y, if I take V1 in x, then both V2 and V3 will be in y. And moreover, we have to check for each edge E1, E2, E3, if one end is in x, the other end must be in y. So, if I consider the edge E1, V1 is in x and V2 is in y. And if you consider the edge E2, the vertex V2 is in y, also the vertex V3 is in y. Therefore, this partition x and y cannot be proper partition. Therefore, this R cycle, that is a triangular graph, cannot be the bipartite graph. So, by the property, we can easily understand that if the graph is bipartite, then it must not contain any R cycle. And hope you have understood the basic concept of bipartite graph and its properties. Thank you all for your patience listening.